Okay, cool. Hello, everyone. My name is Dylan. I'm a second-year PhD student at UCLA, and I'm going to be presenting for the next few minutes our work on DSAGEN, which is sort of democratizing accelerator generation for FPGA overlays. So with an FPGA, there's really two main types to program an FPGA. There's either you manually design the RTL, which is very effort intensive, has a long design time, but it also gives really great performance. And then there's HLS, which is fully automated workflow. You just write your C program, but there's problems with HLS where if you make a small change in your code, you have to do the whole recompilation process. And so our framework is trying to solve or trying to combat like these different programming interfaces. So we're taking in a generalized set of applications and trying to compile to an FPGA using a more coarse-grained overlay. And so a user would just give a bunch of programs. Our compiler will analyze those programs and find different programmatic behaviors of interest, and then we'll be modifying CGRA or similar accelerator and be making it so that it's a high performance accelerator. And so there's really two sort of key ideas. First, on the software, where we'll have like the compiler being able to analyze our program. And then on the hardware, we are able to encode a really rich design space and be really flexible so that we're able to make transformations to the hardware such that it's more optimized for our given workloads that we're having. And so our framework really has four key capabilities. First, we have like multi-threading C programming support. We have this extremely flexible design space. We have this automated exploration of the design space to try to make more optimized hardware. And then our framework is fully end-to-end, so you just write C code, and then you can be able to run it on the FPGA, and we have like full chipyard support. And so sort of our performance, our technique, and sort of programming methodology is comparable with HLS methods, state-of-art HLS methods, but we don't have to deal with the recompilation time if the programmer decides to make like a small change in their application of support. And so I think we're fully on open source and on GitHub if you want to check out the project more. Thank you.